this PowerPoint is actually thanks to Mr. Mitchell. Okay, so 4 credits, external. So language, discrete means like counting numbers. Okay, but we had the exception of dollars yesterday, didn't we? Dollars and cents is actually, you don't get half a cent. Random variable. So a random variable is one whose value cannot be predicted in advance. It's completely random. Instead, we use probabilities assigned to the various variables' possible outcomes. So if you throw a dice, the outcomes are 1, 2, 3, 4, 5, 6, and the random variable is kind of like what's going to happen next time you throw it. You don't know in advance. So it can be discrete and it can be continuous. Expected value. So you have this symbol here, the expected value of random variable x. Now the weird thing about this is when you throw the dice, the expected value is 3.5, which is silly because you're never going to get 3.5. But if you threw it a billion trillion times and took the average would be 3.5. So it's like a theoretical average. Okay, expected value, theoretical average of the values that would be found if it was possible to sample from the variable an infinite billion trillion number of times. This is the symbol used for expected value, and once found we use that symbol, which we often just say the mean, and that symbol means the mean, because it's referred to as the population mean. Okay, find the expected value of the random variable x for a fair six-sided dice. So here's x, lowercase x, takes on the values of the possible outcomes. Possible outcomes 1, 2, 3, 4, 5, and 6. The probability that the random variable x, like the next time you throw it, is going to equal that possible outcome is 1/6, 1/6, 1/6, 1/6. All of these always add to 1. Okay? Here's the formula. So we say I equals 1 to 6. What that's really meaning is that's xi, that's that's x1, that's x2, that's x3, that's x4, that's x5, that's x6. That's just accidental that the numbers are also 1, 2, 3, 4, 5, 6. If it was a different sort of dice, it could be cow, sheep, hen, rabbit, whatever. And then the probability is here. So the probability of outcome x1. Okay, so what does this formula actually mean? It means you multiply that by that. This is the sum, so you add it to that times that, add it to that times that, add that times that, plus that times that, plus that times that. And that ends up 3.5. Okay, the sum of all the probabilities that the big random variable x equals the possible outcome, so all the possible outcomes, the probability adds to 1. Okay? Makes sense? And what does this one here say? I just have to pause a minute. So between 0 and 1, this business here just means a probability of something happening. Can be 0, it can be 1, it can be anything in between, but it can't be, you can't have a negative probability, or you can't have a probability of 110% or 1.1 or anything like that. So that's just fancy maths language for what you should already know. It's kind of formalising it. Okay, so here, find the expected value of x. So here we've got a nice little piece of algebra in there. So the expected value of x equals 2 times k, 2k, plus, what's this? 32k plus 30k plus what is it? 48k, thank you, you're as bad as I am. Okay, so the expected value of x equals, what do they all add up to? 112k? Okay, now what? What other bit of information have we got? K plus 8k plus 5k plus 6k equals what? 1. So can someone add that up? 9k plus 14k, what is it? 20k equals 1. So k equals 1/20th. Okay, so we can sub the 1/20th into here and we get an answer. Sweet? So the trick there was realising that the answer didn't have to have k in it. You actually know that these add to 1. Okay, very cool. Games of chance. For a game of chance or raffle to be fair, the price of entry is equal to the expected winnings. Okay, so that would be that no one's going to make over forever, no one's going to make a profit or a loss. So it's fair. Of course, with gambling, it's never fair because it's always geared for the house to take a cut. Otherwise, they wouldn't be in business. So the expected gain is 0. That makes sense. A lottery has 3 prizes, 2,000, 500 and 100. If there are 1,300 tickets, and assuming all tickets are sold, what should the organiser charge for the tickets if the lottery is to be fair? So do that now. Oops, unfreeze. Oh. There we go. Okay, so what we did here is we put an x and the probability. Is that coming up? No. No. And the probability of x occurring, and then we said x could be, and I'll change my colour pen so it's easier to see, 2,000, and the probability was 1 over 1,300, and 500, 1 over 1,300, and then 100, 1 over 1,300, and 0. Yep. And that was 1297 over 1,300. And the expected value of x was equal to this times this, plus this times this, plus this times this, which was 2. And so, what should the organiser charge for the tickets for the lottery to be fair? $2. Nice? Nice.